Okay, so welcome everybody. This is the second lecture of this week, and building a lot on what we talked about yesterday related to population growth, population declines, increases over time. Today we'll be linking a lot of those concepts that we discussed specifically to diseases and how diseases come into play. So just as a recap from what we covered yesterday, we talked about a lot of these large-scale changes in population growth over time, some of the factors that led to those. We talked about different diseases, as well as different economic factors related to the demographic transition model that we talked about. So today we're going to be tying a lot of those concepts together, really in the context of how this all impacts the spread of diseases, as well as how diseases might impact populations. So we'll get to that today. To start us off, it's important to talk about this fellow. So Thomas Malthus was someone who was particularly obsessed with the study of demography and population shifts over time. So we can't not talk about him in a lecture like this. He was a reverend, a professor, and a scholar of this kind of field, so population theories, demography in general. And what he was really well known for was this essay that he wrote. It was an essay on the principle of population as it affects the future improvement of society. Now, he also wrote a book around the same time that was a summary of the principle of population. So he was really the first person to talk about populations in a way that was particularly concerning. This is in the backdrop of around the same time that the global population reached about 1 billion. So that's sort of the context that Malthus was working around, that all of a sudden the world was a much more populated place than it ever had been before. Now, because of this 1 billion population, he became really, really concerned and convinced that the Earth would not have enough resources to sustain everybody. So you can see that figure there on the slide. He anticipated what we would call some kind of point of crisis, where the population growth would just exceed the amount of resources that were available to sustain those people. So he was very, very concerned about the food shortages that might come about if there were too many people on the planet to support. So that was his main concern. Now, what were his main theories? How did he talk about population? What were his thoughts? Well, he can kind of divide that into two main theories or two main ideas that he had. The first, he was a bit of a pessimist in that he thought this crisis point was inevitable since all humans need food. And second, that passion between the sexes, as he called it, was necessary and inevitably will remain. So he figured that those two things were not going to change, right? People still need to eat lots of food and people are probably going to keep having babies. So he was a pessimist in that sense. The second part of his theory there was this idea around positive checks. So contrary to many beliefs at the time, which actually valued large families, valued high fertility rates because countries saw it as a way to showcase their national wealth, right? The more people they had, the more labor they had, the more kind of strength they had on the global stage. But he was contrary to this. He argued that societies really need to tackle this idea of overpopulation, that population shouldn't be something they should be proud of. In fact, it should be an issue that they tackle. So what did he advocate for? He advocated for something that are called positive checks. Now, these could happen naturally by the way of plagues or famines. So these would be events that would shorten the natural time span of human life or the expectancy of human life. This could also happen through wars. But he also talked about preventive checks. So not these sort of gloomy scenarios, but more so things like family planning, what he called moral restraint, which we can assume meant something along the lines of sexual abstinence. So this was his idea around positive checks, that we needed those checks to make sure that we keep the population in balance, that it doesn't go overboard. Now, some interpreted Malthus to be advocating for positive checks in a way that might support contraception and female empowerment. But remember that he was a man of the church, so it's probably not very likely that that's what he was actually saying. He probably more so meant the sexual abstinence part. But that's okay. Some people might have some wishful thinking there. Now, he was surprised to find maybe a few years later, after all of this kind of kerfuffle around the 1 billion population mark, that population didn't really experience this point of crisis that he anticipated. In fact, as the century went on, technology kind of saved the day. There was what we call the agricultural revolution, which was huge. It was the mechanization of farming around the time of the 18th as well as 19th century, so around the time that industrialization took place. And this really changed the game because food shortage was no longer this concern that people had to have. The crops that people were growing could be done much more efficiently. And so we never really experienced those kinds of food shortages that they anticipated. That being said, other factors started to come into play, especially towards the 19th and later 20th century. This included later marriages, the use of contraceptives, and females entering the workforce, of course. So these all had a really important factor to play on keeping populations in check and making sure that they didn't go too overboard, especially in industrializing nations. But Malthus did leave a really profound impact on the study of demography, and he inspired many scientists, many other future demographers that would come on the world stage later on. So these people we call NeoMalthusians, new Malthusians essentially. And many of them are what we call modern day advocates of population planning. So many of them have certain theories that contraception and family planning should play a much bigger role in order to keep global populations in check. Neo-Malthusians also tend to side on this environmental realm of thought, where they think that population planning is necessary in order to avoid environmental degradation, climate change, wide-scale pollution, things like that. But their thinking has also erred on some very kind of controversial sides. So one side of that is certainly an example of China's one-child policy, right? So that's an example of a family planning kind of policy that was implemented. But there's other controversial policies that were implemented even before that. So eugenics, for anyone that doesn't know, is a really, really controversial selective breeding type of policy that took place, especially in the sort of earlier 20th century and throughout World War II. This was advocated for, where people wanted to sort of breed out these undesirable traits as they saw it in certain humans. And so for obvious reasons, that is extremely unethical and not okay. But many people do still have some tendencies to think in this way, right? In essence, if we're telling certain developing nations that they need to control their population, they need to limit the fertility rates, that is one form of coerced population control, you could argue. So it does still kind of have these very controversial sentiments around it. But as you can guess, many of these sort of neo-Malthusian theories are still advocated for on a global stage. Many people do still hold certain beliefs that we would classify as neo-Malthusian. So it's by no means a theory that has kind of disappeared. People do still advocate for a lot of these types of policies and population control plans. This brings us to limits to growth. So this is another example of sort of neo-Malthusian theory. And it was a book that was published back in the 70s by a team of MIT researchers. This team developed a computer model that looked at the way that economic and population growth were constrained by 5 main factors. So those 5 factors are listed on the slide there. They're population increase, agricultural production, non-renewable resource depletion, industrial output, and pollution generation. So these researchers were also quite concerned about the levels of population growth in the world, and they got together and they wanted to know what are the factors that could really help us potentially control this issue of overpopulation around the globe. So they concluded that humankind could survive on this planet based on the amount of resources that are available to us, but that it would take some pretty strict restrictions on the production of goods and human population growth as well. So they really advocated for concepts that we've come to know, especially in environmental science, things like carrying capacity. So making sure that we have enough resources on the planet to fully sustain populations that live here, and also partially to ensure that other impacts on ecosystems are not seen just because of human consumption and populations. So this brings us to global disease trends. Now, the rest of today's lecture will really try to shine a light on the state of health and disease around the globe. We'll talk about why some diseases strike in some parts of the world, as well as where the diseases are likely to have the biggest impacts on populations. So that's kind of the links that we will make there. So I want to ask you guys, what are common diseases around the world? And which ones cause the biggest impact on population growth? Malaria, HIV. Any others? Cholera. What are other common diseases? COVID, yeah. In today's context, that definitely can't be ignored. Influenza, yeah. Anyone else want to chime in? E. coli, Zika virus. Heart disease, yeah. So I do think it's interesting that a lot of you started off with infectious diseases, which certainly capture most of our attention. But you're right, Savannah, heart disease and other chronic diseases are also really, really important, but maybe don't get as much interest from people. So that's an interesting thing to note. Well, let's take a look at one of those diseases. So this concept of the global disease burden comes back to us. So we talked a bit about this back during week 1. So the burden of disease is that total impact of a health problem in a region or a country. And usually it's a sum of mortality or morbidity or some kind of economic statistic. Sometimes it's all 3 of those. So in this case, this map is showing the burden of nutritional deficiencies. So malnutrition, in other words. And it's showing us the years lived with disabilities, YLDs. So what can we tell from this map? That something like malnutrition is really, really concentrated on the continent of Africa, as well as some other nations like India around the world, but really focused in on a certain continent in this case. Now, the biggest cause of deaths globally is actually heart disease. So this is probably a surprising statistic to many people because heart disease is not one of those things that we tend to talk a lot about. Certainly here in Canada, we talk, I think, more about things like cancer, maybe stroke as well, captures more of our attention. And globally, we do tend to focus really on those infectious diseases that a lot of you talked about. But heart disease, on average, still kills the most people around the globe. So that's something that's important to note, and maybe it would come as a surprise to many of us. Thanks, Regina. See you next week.
Bye, everyone.
So what are the top risk factors associated with a lot of those diseases that we saw on the previous slide? Well, you can look at this from one perspective as a change in time, because there have been some pretty substantial changes over time as to what causes those diseases that we talked about. So for example, about 30 years ago, back in 1990, child wasting, low birth weight, short gestation, right? These are all aspects of maternal health, which really had a significant impact on health back then. Compare that to 2019, so about 30 years after that, things have changed a little bit, right? So instead of a lot of those maternal health factors, the leading risk factors have now become things like blood pressure, smoking, and a different range of different risk factors. Now, I should mention here that the colors correspond to different categories. So in case you guys are curious, the blue categories are these behavioral or nutritional risks. The red are environmental risks, which is probably a little bit obvious there, things like air pollution. And then the green are what the WHO calls metabolic risks, so things specifically related to the biological systems in the body. So that's interesting that there have been some changes over time, and this has certainly impacted different populations differently around the world, right? Smoking maybe isn't a factor that would be as common everywhere around the world. Let's take a look. So this is tobacco's impact on dailies. And remember, dailies are the disability adjusted life years. So it's another way of looking at the burden. Instead of looking at mortality or morbidity, it quantifies the life years that are going to be related to poor quality of health. So what do we see based on this? Well, that there's significant variation. Even though we know tobacco is a risk factor for many diseases, most notably lung cancer, it doesn't necessarily have the same impact everywhere, because certain regions of the world have a much higher smoking rate, firstly, and that contributes to a different burden of disease specifically from tobacco. So what's notable here, that places like China, the risk isn't equal across the country. There are certain areas where smoking is much more prevalent. The same can be said for Europe, right? In the east of Europe, smoking rates are much higher. And interestingly, in the States, the smoking rates vary quite significantly. So in places like, I believe this is West Virginia, the smoking rates contribute to a much higher attributable daily, so those impacts on the life years compared to other states. Now, where has the impact of the opioid crisis been the largest globally? What do you guys think? If we take a look at a global map, what do you guys think will be the sort of hot red zone? The US? Yeah. Does anyone else have an idea? UK? Canada, North America as a whole? Okay, let's take a look. Yeah, so for anyone who guessed the US, that is correct. Yeah, so these are YLDs, which we know again are those years lived with disability. So it doesn't necessarily tell us the impact of overdoses. That would be a different statistic. But this tells us the burden of sort of living with a substance abuse related kind of addiction for opioids. So it's a bit of a different statistic. So if you thought maybe that mortality from opioid overdose might be higher in some areas, that it might in fact look a little bit differently. But this is the burden of just using opioids and how that impacts quality of life and living with addiction, basically. So yep, the highest would be in the States, but Canada is not that far behind. It's sort of in the middle of the road compared to other countries. And then you see the spread across the globe. So something that we could glean from a map like this is that it really has been an unequal proportion of sort of suffering due to opioid use and addictions, particularly centered in the States. Now, let's talk about some shifting global disease burdens over time. Many of you talked about, again, those infectious diseases as contributing to population declines potentially in the world. And you would have been right, especially among lower income countries, right? So this is specifically looking at low development index. And back in 1990, certainly infectious diseases played a very significant role on mortality, on the death toll. So these orange are signifying communicable, also known as infectious diseases. But contrast that to 30 years later in 2019, things started to change even in the lower income countries, right? So no longer is it tuberculosis in the first spot, cardiovascular disease was now taking up the first spot, which is a chronic non-communicable disease. And there are certainly more chronic diseases sort of mixed into the top 10 spots. So things are slowly shifting. The global disease burden is moving from more infectious diseases to more chronic diseases, especially as industrialization and economic development continues to grow in many of those lower developing sort of areas of the world. Let's contrast that with higher development or higher income nations. So back in 1990, cardiovascular disease was the first spot, as well as cancer, and that has not changed. So overall, the burden of disease, specifically looking at mortality, so deaths, it hasn't changed significantly in the last 30 years among the higher income nations of the world. So the trends compared to lower income nations are definitely a little bit more. So isn't there a theory in geography that says we might shift back to infectious diseases? Yes, and we will talk a little bit about that. I believe it's next week where we start talking about infectious diseases. So we will talk about this, and as well, if any of you have heard of the term double burden of disease, where some nations might tackle both infectious diseases and chronic disease at the same time. Yeah, we'll talk about that a little bit more in the weeks to come. So stay tuned. Now, do global disease patterns influence economic development? And if so, how? So what do you guys think? Is there a link between diseases and economic development? I'll give you guys some time to type out a response. If there's more people that can't work and requires substantial medical care, that can bring the economy down. Yeah. Nicole, you're right. We can see how COVID has affected the economy. There's more people affected, the less work that's being done. Yep. If people aren't well, they can't work. Exactly. So yeah, you guys are right. If less developed nations are putting a lot of resources in dealing with diseases, they have less resources to put towards developing economically. Yep, also true. So they're kind of dealing with the burden of disease, tackling diseases, and maybe poor medical infrastructure, and that might certainly impact their economy. Great. Yeah. So for those of us who maybe need a refresher about what these concepts are, how do we even measure economic development in a country? That's really tied to certain indicators, certain economic values that we look at in particular countries. So organizations will take various factors into consideration when they classify a nation as sort of lower income developing or industrialized. And there's many different terms out there for how we actually call these countries different things. So unfortunately, there's not a whole lot of consistency there. But in general, you tend to look at economic output indicators, so things like GDP, GNI, which is gross national income, labor productivity, employment statistics. But increasingly, we're also looking at things related to health. So for example, if a country has universal healthcare coverage, that would obviously impact the economy because more people are probably not going into bankruptcy if they have a medical issue, right? If there's universal health coverage, then they can spend that money on goods and services instead of medical care. And the IMF most notably considers per capita income and export diversification, as well as how much their economy is integrated with global financial systems as an indicator of development. So there's many different ways to actually classify that. And I should say that the whole concept of development is a little bit controversial because naturally, even if a place doesn't have what we would call high economic development, it doesn't mean that their social systems are somehow undeveloped, right? It doesn't mean that the people there are of any less value than a higher income industrialized nation. So I definitely do want to make that clear. And in fact, many of those developing nations can trace back a lot of their economic woes, specifically to colonialism and what happened many decades ago. So it's a much more complicated issue than that, but to kind of avoid going out of the scope of a course like this, we'll try to simplify things a little bit. But it's important to kind of keep that at the back of your mind, that this idea of development is certainly not without controversy. So let's look at one of those indicators, GNI. So I want you to just sort of remember this map in your head, right? Taking a look at where GNI is highest, gross national income tends to be centered around those industrialized nations, as we call them. So certainly the US, Canada, Australia, Western Europe, as well as Saudi Arabia. Now, how does that compare with something like life expectancy, right? Is there a link between income or economic development and potential health? You might have guessed, yes. So similarly to that previous figure, life expectancy tends to be highest in those places where the GNI was very high, so where economic development tends to be higher. There are, of course, some exceptions. So we saw here that the US, for example, drops off a little bit. And I think for some pretty obvious reasons, we might guess why, especially related to their healthcare system. So it does have quite a significant impact on life expectancy in the States, as well as, of course, other factors like lifestyle and just unhealthier behaviors could certainly play a role. So another way of looking at that kind of relationship is with GDP. So a very similar kind of trend emerges here, right? So GDP per capita on one axis and life expectancy. So both of those experience this positive association. So the more GDP per capita a country has, the higher life expectancy it tends to have. You'll notice on this graph that unfortunately a lot of African nations kind of cluster in this bottom part of the graph. So there are certain regional differences that economists are obviously very interested in studying and considering in terms of what their impacts might be on potential population growth in the future, as hopefully some of those economies do expand and grow over time. Now, nations that are considered less developed do face a lot of discrepancies. They face resource shortages, as some of you kind of touched on in your comments. There's not enough income to support a tax system, for example, which might support a better healthcare system. So a lot of these things are very, very tied closely together. And we will talk about those things much more later in the course when we address some of those socioeconomic determinants of health. But it is important to note that diseases are still quite common in even affluent countries. They just might look a little bit different. So how does economic growth impact health outcomes? Well, it's a little bit mixed, right? Even though life expectancy might be higher in those higher income nations, their quality of life might be significantly impacted by things like chronic diseases, which may not kill you right away, something like an infectious disease might. But certainly a lot of those chronic diseases that we live with for many, many years do have an impact on the quality of life of people who live in higher economic regions. So it's important to kind of keep those relationships in the back of your mind. Now, if we think about that relationship that we just established, right? That higher development usually means better health overall. It's interesting to note that that relationship isn't true for some diseases. And breast cancer is one of those diseases that's a bit of a funny one. It's a bit of an exception to a lot of those rules because breast cancer rates are significantly higher in higher income nations, right? So we see that relationship play out in the two figures here. So the first one, this figure on the left, is looking at the GDP per capita. And as you can see, as GDP grows, then the incidence of breast cancer grows. Put differently, this study was looking at grouping particular nations, so grouping the higher income nations compared to the middle income and lower income nations. And again, a similar trend emerges where the higher income nations tend to have higher incidence rates compared to lower income. Now, why do you guys think that might be? What differences might account for these types of differences in incidence rates specifically? Any ideas? Increased consumption of processed foods. So diet playing a particularly important role, certainly. Any other ideas? Higher use of oral contraceptives, interesting. Less screening for breast cancer. Yeah, so definitely a factor. Maybe more developed nations import most of their foods. Yeah, so again, related to diet. Yeah, and I will touch on that oral contraceptives comment because I think it is an interesting one. The link between oral contraceptives and cancer in general is a little bit muddled. So there's no strong evidence that would suggest a relationship there, but certainly some studies have linked it to breast cancer. Others have related it to a lower incidence of ovarian cancer. So it kind of has this double-edged sword where you might be improving the outcome of some cancers, but not the others. So yeah, the oral contraceptives point there is a very complicated one. And I think many cancer researchers are very unsure about the impact there. But let's talk about that. So you guys have mentioned things like screening. And yeah, screening could definitely be an important one. So that might be a difference between the healthcare systems between higher income countries and lower income countries. Maybe women in lower income countries don't have access to something like a mammogram. So that would definitely have some impacts there. But let's look at two countries that have very similar economic development levels, two kind of global economic powerhouses, which are Japan and the US. And let's take a look at their breast cancer rates. So what do we see in terms of trends? Well, the US rate is quite a bit higher than the incidence rate in Japan. Mortality as well is higher in the US than in Japan. But something that's worth noting is that in the last couple of decades, the incidence rate in the US has started to decline, whereas the incidence in Japan during that same period approximately has increased. So researchers have been kind of scratching their head as to why this potential difference in outcomes might be happening. And certainly it might just be a bit of a fluke, right? Maybe they'll have to look at this relationship more closely over time to see if it is a sustained trend. But they are a little bit concerned as to what is happening. So one thing that we can note is that a lot of the factors that you guys talked about, things like diet, certainly do play a role in cancer outcomes, cancer development, and the risk of cancer. So perhaps poor diets could lead to this overall higher incidence rate in the States. That's definitely a theory that I think is pretty well supported. But something like incidence rate, in terms of the growth here in Japan, what do you guys think might be happening in Japan that might lead to a difference in the incidence rate? Why would it be increasing in Japan versus decreasing in the States? Any ideas? So we know that economic factors might not be at play. Aging population, yeah. Although I should say that I'm pretty sure these incidence rates are age standardized. So they do definitely want to factor in for age, because cancer, of course, we know does tend to be a disease that's much more prominent, more prevalent in older age categories. Any other ideas? Nuclear explosion, maybe? Yeah, certainly radiation is a cancer risk factor, so I guess we can't really discount that. Side effects from human disasters, World War, yep. Any others? So what scientists think is happening in Japan is actually related to estrogen. So I forget who mentioned estrogen earlier, but you kind of had a point there. So as we know, estrogen does play an important role in the development of breast cancer. And the more that Japanese women tend to delay things like pregnancy, right? Because people are choosing either to have smaller families or not have children at all. They're delaying their pregnancies to a later age because they want to be in the workforce for longer. So that does have an impact on the estrogen regulation in your body. And so scientists think that there might be a link there in terms of having those later or less frequent pregnancies leading to differences in the estrogen response of the bodies of Japanese women compared to American women. So that's sort of the hunch that they have. But in general, what I kind of want you to take away from a slide like this is that even two countries with very similar economic development, similar economic strength, certainly on a global scale, can still experience trends in diseases in very different ways. So it's important to look at a multitude of other risk factors when you're talking about diseases. Now let's talk a little bit about that. So one of these factors are genetic. So I want to introduce this concept of genetic drift, which is a change in the frequency of a gene in a population from one generation to the next. And these changes in the gene frequency can become really extreme the smaller the population is. So this change can be due to something like chance, right? Could just happen naturally that there's a change in that frequency of a gene, but also it can happen due to geographic barriers. So specifically things like restricted migration can cause populations with a specific set of genes to be located in one particular area of the world, or these genes can then cluster if that population is very isolated in that geographic space. It can also happen due to something like epidemics. So if an epidemic kills or wipes out a significant portion of one population and maybe only leaves a few surviving members, then those surviving members are going to be overrepresented in the next generation, right? Their genes are going to be the ones that get passed on. So these genetic factors can definitely also come into play anytime we're talking about changes to populations, whether it's declines and then increases. So it's important to note. Now, one type of genetic drift, one of these examples, is something that we call the bottleneck effect. The bottleneck effect happens when a population's size is reduced to such an extent that the genetic variation is actually reduced. So you can see that play out here in the figure, right? We have a very diverse population at first, this parent population, and then due to some event happening, this could be something like a war or an epidemic, something that really forces a contraction in the population. We are left over with a smaller number of surviving members who maybe only have a certain sort of biased representation of the original genes. So an example of that was actually the Black Death, which happened back in the, I think, 1400s. And so that killed about 1 in every 3 Europeans. Massive, massive impacts on the surviving population in terms of who was left behind. And experts actually think that the genetic diversity in places like England is significantly lower than it was back in the 11th century prior to the Black Death. So they think that it's still had this sort of ongoing impact on the genetic diversity in the current population there. So that's an interesting thing. Now, another type of this genetic drift is something that we call the founder effect. So the founder effect specifically happens when a small part of a population relocates to a new environment, to a new geographic setting, and then the frequency of those founders, the frequency of the genes in those people is going to be disproportionately higher in that new population wherever they end up settling. Now, a pretty well-known example of that is actually in the Amish who live in Pennsylvania in the States. So the Amish in Pennsylvania can trace back their lineages to about 200 people that originally made the migration from Germany into the States in sort of the early periods of the United States. And so what happened due to that? Well, something called Ellis Van Creveld syndrome was particularly overrepresented in those original 200 people that came from Germany for whatever reason, may have been just sort of fluke. But once they settled in the States, then their genes with the syndrome became obviously much more common as the people sort of intermingled with one another and formed a very isolated genetic pool in Pennsylvania. Now, this syndrome is well known because it involves symptoms like polydactyly, which for any of you that don't know is when you have extra fingers or toes. So this is something that is seen in the Amish in Pennsylvania. In fact, many of them do have this prominent sort of impact from this founder effect. They have extra toes and fingers. But another interesting example of this happened in the early 1990s. So back then, health officials in New York State, specifically in Long Island, noticed that they had a higher incidence of breast cancer and ovarian cancer on Long Island. And they were confused as to why that could be. They had ruled out things like lifestyle factors. They knew that the population there wasn't any less healthy than other populations that they were comparing it to. So they were a little bit confused as to what was going on and what could have led to this increase in rates of breast cancer. What they started to figure out around the same time, right, so this is in the 1990s, is that breast cancer incidence is quite a bit higher among women who have a specific genetic mutation. For those of us that have come to know these genetic mutations, maybe even people in our families might have been impacted by breast cancer. It is a very common disease. So we know that that's the BRCA gene, the BRCA1 and BRCA2. So what did they discover? Well, they actually realized that the prevalence of those genes, the BRCA genes, are more prevalent among women of Ashkenazi Jewish descent. And what did they know? Well, they know that on Long Island, there's actually a very strong population, a very large population of women of Ashkenazi Jewish descent. So they started to realize that it might have actually had an impact on the rates of breast cancer on Long Island, just because of the genetic kind of pool that was found on Long Island. Now, how does that actually translate to differences? Well, it's said that Ashkenazi Jewish women have about a 2% higher risk. So that means 1 in 40 women are going to be carriers of that gene, compared to the general population, which is about 1 in 300 women. So that's a pretty significant increase in risk. Now, I should say that having the gene doesn't automatically mean that you'll get breast cancer. It just means that you will be slightly more likely. And the amount of risk that it increases does change. There's a few studies that float around some different numbers. So it's not set in stone that you'll be diagnosed with breast cancer. I definitely don't want to say that, just that you will have an increased risk of it. Now, why does this happen? Why do women of Ashkenazi Jewish descent have potentially higher risks of having these genes? What's going on there? Well, scientists think that both the founder effect and the bottleneck effect may have played a role there back in kind of earlier history. So Ashkenazi Jewish women and this type of Jewish people specifically can relate their lineages back to Europe, and many of them around Eastern Europe. And so they think that because a lot of them faced persecution in Europe, especially in places like Russia, but also beyond, something that we call pogroms. So because they faced a lot of discrimination, a lot of attacks, and occasionally population declines due to massacres and things like that, they think that that might have been enough to actually cause a contraction in their population, which may have led to that decrease in genetic variety. So maybe it became more prominent of a gene in that kind of leftover pool of people that had survived those attacks. But also, if you think about this founder effect, so what do we know about Jewish populations, especially in Europe at that time, so in the sort of earlier 20th century, is that a lot of them were very isolated communities. They lived in very specific neighborhoods in particular cities, and they didn't necessarily mingle a whole lot with outsiders. They were very sort of inward communities. What we call ghettos were prominent in many European cities. And so it may have sort of led to an even increased risk of these genes getting passed on because there wasn't a whole lot of mingling in their genetic pool. So that's to say that population movements, population migration can definitely have a really profound impact on diseases and disease trends globally. And they might not even be centered in the original places where those people lived, right? Because of migration, people can transfer diseases and their genetic variants for particular diseases into new places all over the world. So this certainly complicates the relationship in terms of geography and disease and people's risk, which may be influenced by their new location instead of their old location. So things can get pretty complicated pretty quickly when you take all these factors into consideration. So I'm gonna end the lecture there because this will actually segue pretty well into what we talk about next week. And we'll spend some time talking about some of these genetic factors that come into play. So stay tuned for that. So that's all for today. Thanks, everybody. And enjoy the rest of the snow day today. Have a good week, everybody.